Hello students. Today we're going to move on to chapter or section 2.1, multiplying fractions. There are two different methods of multiplying fractions. Method one, you multiply the numerators or the top number and multiply the denominators together and then reduce the fraction if needed. Method two, and this is the method that I kind of like the best. I'll kind of about why. Move on. But first, cross cancel. What you're doing is really cross simplifying. It's kind of doing the reducing of the fraction, kind of one at the beginning, and I'll show you that as we go through a problem. Then after you cross simplify or cross cancel, then you multiply numerators, multiply top numbers, multiply denominators, and then see if you need to reduce any more. So 2 and 3 are just 1 and 2 on method 1. But you're going to kind of simplify at the beginning and not simplify at the end like method 1 on method 2. So we're going to do the same exact problem using the two different methods. So method 1. So we're going to multiply first. Method 1 says to multiply numerators. So we're going to multiply 8 times 3. Multiply denominators, 9 times 4, and then reduce or simplify if needed. So let's go ahead and do that. So first, multiply numerators. So we're going to multiply 8 times 3. That gives us 24. Then we're going to multiply the bottoms. We're going to multiply 9 times 4, which I believe gives us 36. And then we want to go ahead. So we did step 1 and step 2. That's step 1 and step 2. Now we just got to see, can I simplify? Can I reduce 24 and 36 by a number? And the answer is yes. I can actually divide both of these by 4. Remember, when we're reducing, both numbers have to be divided by the same number. I usually see a lot of people dividing by two different numbers. The number that's in red here has to be the same number. It can't be two different numbers. You have to divide both the 24 by 4. So 24 divided by 4, I believe, is 6. And then 34 divided by 4, I believe, is 9. Well, we got to look again. Can I simplify again? Can I simplify 6 over 9? The answer is yes, I can. I can divide this again, both top and bottom. I can divide both top and bottom by the number 3. And when I divide both top and bottom by 3, it gets simplified a little more. And you have to keep going until you can't simplify anymore. So let's go ahead and do the division. 2 divided by 3, 6 divided by 3, excuse me, is 2. I was going right to the answer. 9 divided by 3, of course, is 3. And this is our simplified answer. You can't divide 2 and 3 by any number but by themselves. So this is our simplified answer or reduced answer. So now we're going to do the same problem. As you can see, we actually could have simplified the first one by 12 right away. If we notice that on 24 and 36, I just wanted to do a two-step division. See, that's okay to do it twice if needed. Here we're going to use method 2. Method 2, we're going to use this thing called cross-cancel, or cross-simplification. So what we're doing is we're looking across the fraction. So we're looking at one numerator, so we're going to look at the 8, and we're going to look across the fraction to the bottom, kind of using this x, and we're going to look at the 4. So let's go ahead and look at these two numbers. Can I divide 8 and 4 by a number evenly or nicely? And the answer is yes. I can divide both of these by the number 4. So what we're doing is we're doing the simplification. We're doing the part in red in method 1 or on problem 1 first. As you can see, I divided by 4 here. I'm dividing by 4 here. So we're going to cross cancel. 8 divided by 4 is 2. So that's our new numerator, 2. 4 divided by 4 is 1. That's our new denominator. And now I'm going to do the same thing with the 8 and 9. Can I cross cancel 8 and 9? The answer is yes. I can divide both of these by 3. And of course, that's the second part of our simplification on problem 1, or our reducing. Can you always cross cancel? And the answer is no. But on this one, you can do it both ways. 3 divided by 3 is 1. 9 divided by 3 is 3. See, as you can see, when you cross cancel, these numbers become nice and small, and that's what we want. Now all we gotta do is multiply the tops. Well, 2 times 1 is 2. 3 times every single problem. And you can't all. So let's go and look at a couple more examples. I'm going to use cross cancellation every time I can. I think that's the best way to do it because it makes the numbers smaller. Okay, do you have to? No, you don't have to every time, but it does help. So we look at this. This is 4/7 times 5/6. And the question is, can I cross cancel 4 and 6? The answer is yes. I can divide them both by 2. So 4 divided by 2 is 2. I'm not going to show the division. I'm just going to tell you it. 6 divided by 2 is 3. So I divided both these in blue, or both these numbers, by 2. Can I cross cancel 7 and 5? And the answer is no, I can't cross cancel those. So the next step is just simply multiply them across. 2 times 5 is 10. 7 times 3 is 21. You always want to kind of double check. Can I divide 10 and 21 by a number nicely? And the answer is no, you can't. You can't divide 10 and 21 by any number nicely. 2 times 5 gives you 10. 2 times nothing gives you 21, or at least not a whole number. 5 times nothing, at least not a whole number, gives you 21. So you can't simplify this down anymore. All right, let's go and look at another one, number 4. Always want to look to see if I can cross cancel. Can I cross cancel 2 and 5? Does anything go into 2 and 5 nicely? No, because the only thing the way I get 2 is 2 times 2 and 1. So 2 would work here, but would 5 divided by 2 work? No, it gives you 2.5. That we don't want fractions on fractions. We want it to be nicely. So I can't cross cancel 2 and 5. Can I cross cancel 1 and 3? Well, whenever you have a 1, that's as low as you want to go. You don't want to make a number smaller than 1. So you can't cross cancel any of these here. And sometimes that will happen. Don't be surprised at that. You can't cross cancel everything. So now all we got to do is multiply across. 2 times 1 is 2. Multiply across the bottom. 3 times 5 is 15. At the end, we always want to double check. Can I simplify down this fraction? Can I divide both 2 and 15 by a number nicely? The answer is no. 2 is prime, so that means 2 can only be divided by 2. So you have to ask yourself, can 15 be divided by 2 nicely? And the answer is no. It gives you 7.5. That's not nicely. We want to make a whole number. All right, so that's the first video. So you can go ahead and stop this video and go and move on to video number 2. We're going to go over one more problem together, and then you're going to try a couple on your own. All right, hello students, welcome back. We're going to go over one more problem together, and then you're going to try a couple on your own. So here we have a whole number, 5 times a fraction, 5/6. Well, remember in the methods 1 and 2, we had to multiply numerators together, so top numbers together, and denominators together. Well, this doesn't have it right now. We have to create it. So whenever you have a whole number, to turn a whole number into a fraction, we simply take the whole number, put a fraction bar underneath it, and put it over 1. Remember, we learned in chapter 1 that this is actually a division problem. This says 5 divided by 1. 5 divided by 1 is the whole number 5. So that's an easy way, or that's exactly what you're supposed to do to turn a whole number into a fraction, is to simply put it over 1. So now I always like to check method 2. Can I cross cancel? Well, if my denominator is 1, I can't cross cancel with the other numerator because 1 is as low as we want to go. We can't change 1 any smaller or make 1 any smaller. So this can't cross cancel the denominator of 1 and the top of 5. Can the numerator of 5 and denominator of 6 cross cancel? The answer is no. 5 is a prime number. Only 5 can be divided by is 5. Can I divide 6 by 5 nicely? And the answer is no. So all we can do is multiply numerators and multiply denominators. So we multiplied the top. 5 times 5 is 25. I multiply the bottom. 1 times 6 is 6, excuse me. And now I end up with a fraction. This is called, if we remember, an improper fraction. The top number, the 25, is bigger than the bottom number. Our answer cannot be an improper fraction. Our answer has to be converted. We don't want the top number to be bigger, so we have to do some division. Remember, we also learned this in chapter 1. I just said it over here with the 5. This means division. 25, the top number, is being divided by or divided into 6 groups. So on the side, we do the work. So we make our division house. The bottom number goes on the inside, and we spent the whole worksheet going over this. The top number goes on the inside. Please don't say the bigger number. The bigger number does not always go on the inside. We'll kind of talk about that as we get to the end of chapter 1 or chapter 2. And now I divide. Can 6 go into the number 2 or the digit 2? And the answer is no. So we kind of put a place value holder there. Can 6 go into 25? And the answer is yes. It goes in 4 times. Why? Because 4 times 6 is 24. That's very close to 25 without going over. Now we go ahead and do the subtraction. We go ahead and we get a 1. Since there's no other digits after the 5, this is called a remainder, and in 6th grade we write it as a fraction. The remainder comes to the top of the fraction as a 1, and the denominator, or the 6 over here, stays the same. So the answer is 4 1/6. All of your answers have to be converted into, oops, almost put a 6 there, into mixed numbers. You cannot have an improper fraction as a proper answer. All right, so there would be your answer. We want to make sure we always do that conversion when needed. Otherwise, it's not completely converted correctly. All right, we have 2 things going on, or 2 questions you can do on your own. First, question 6, you can use method 1. And then in number 7, you can use method 2. You're going to try to cross simplify first. So go ahead and pause the video. Go ahead and work this out, and then come back and I'll show you how you should have gotten the answers. All right, here you go. Number 6. So method 1, we multiply across. It gives you 6. 3 times 2 is 6 over 21. And now we have to look to see, can I simplify it down? And of course, the answer is yes. I can divide both top and bottom by 3. And of course, 6 divided by 3, I was right, is 2. 21 divided by 3 is 7. And of course, this is what you should have gotten for question 6. Okay, and of course, as you can see here, the 3's are across from each other. Sorry for number 6 real quick. You could have actually canceled both of these 3's out and made them 1s. As you can see, 2 is the top, 7 is the bottom. So let's go ahead and look at now question 7. We're going to use some cross canceling if we can. So let's go ahead and go through it. So first, can I cross cancel 4 and 10? And the answer is yes. I can divide both of these by 2. So as you can see, I'm dividing both of them by the same number. I'm dividing them both by 2. So 4 divided by 2 is 2. So 2 is a new numerator. 10 divided by 2 is 5. And now I look to see, can I cross cancel the 3 and the 9? The answer is yes. I can actually divide both of these by 3. So hopefully you caught this cross cancellation. If you did not catch this cross cancellation, please stop the video and rewrite the problem below this and then do the cross cancellation correctly. Your answer still might be correct, so please don't erase your answer just yet. Rewrite the problem, 4 over 9 times 3 over 10, do the cross cancellation like I'm doing, and then check to see if you get the same answer. So 9 divided by 3 is 3. Sorry, I just wanted to stop and go over that before people start erasing. 3 divided by 3 is 1. And now I go ahead and I can multiply across the top and across the bottom. So 2 times 1 is 2. 3 times 5 is 15. So if you didn't catch both of the cross cancellations, but you might have caught one of them, you could have simplified at the end and got the same answer. So that's perfectly fine. Otherwise, because some people might have caught the 9 and 3, you can divide by 3, but might not have caught the 2 and the 4. Sorry, 10 and the 4. Okay, you might catch one of them, you might not catch both. But what's nice about the cross canceling is it keeps the numbers nice and small. If I was to multiply this across, I would have 12 on top and 90 on bottom. That makes some big numbers. Now, that's not too big, but they will get a lot bigger if we don't use cross cancellation. So please always look to see if you can cross cancel. Now, if you don't understand how I cross canceled this, please raise your hand so I can come by and help you out. You need to make sure we're cross canceling appropriately. This is not just for fractions. We're going to use this for other things in 6th grade as well. All right, otherwise you should be good to move on to your assignment. Go ahead and stop the video and move on to your assignment for the day.